All right, you're almost done. If we have a sheet called the Block 2 Summaries, and the big takeaway is that you can write down the analytical solution. There's this preamble that, as a mathematician, I need to have. In all of these, you need to assume that it's a k by k matrix with k distinct eigenvectors, and then you can expand like this. And in this case here, I have only 2 eigenvalues and 2 eigenvectors, so I would only have this part right here plus p star, and that's the analytical solution. You're supposed to input in each piece separately on WebAssign, but the whole point of this is that you're eventually going to write down a solution like this. We actually played with it in class. We'll do it a couple more times. But you can plug in any value of n, let's say n equals 50. You can plug it in here, and you can write down the what p sub n at 50 is by just plugging in, just like you did in block 1. It's just a little bit more complicated and messy. I do have another crib sheet that once you have the solution, you can put it in there and you can type in what n is, and it will do the calculation for you. There's a lot of arithmetic here. Last question is to select the long-term behavior. I already know it's divergent because I can see that on Excel. It's divergent. A sub n and b sub n go to infinity. But you can also tell that from the eigenvalues. And so the reason is because if any one of the eigenvalues is bigger than 1, I'm in this slot down here. So it's the eigenvalues take the place of little a from block 1. And if little a was bigger than 1, then you would have divergent. And here, the equilibrium value vector would be repelling. And the magnitude of the eigenvector, the distance vector, would go to infinity. We don't have that in the book, but that's how we would say it. Of course, if you start at the initial condition at p star, then the limit would be p star still. So this is the block I'm under, so it falls under being divergent and repelling, and it's because one of the eigenvalues is bigger than 1. So if I go here, you see why the answer is divergent and greater one eigenvalues. The largest eigenvalue is greater than 1. So that's why we have what we have, and that's how you make the conclusion.